Hello students, this is Dr. Sourav's class. We are now solving our UPSC mathematics paper, which is our mathematics optional paper from 2024. So our question appeared in that paper. So that question is from our vector analysis chapter. So the question says us to state the Stokes theorem firstly, and then we have to verify it for the vector field f equals to xi cap xy I cap plus yz j cap plus zx k cap over the surface S, which is upwardly oriented part of the cylinder z equals to 1 minus x square for 0 less than equals to x less than equals to 1 and minus 2 less than equals to y less than equals to 2. This can be a rectangle, no? Yeah, okay. So firstly, what our Stokes theorem says. Yeah, okay. So firstly, our Stokes theorem says relate to the surface integral of the curl of a vector field over a surface S to the line integral of the vector field along the boundary curve del S so mathematically it is this. Firstly, we are writing our surface integral of the curl of F with the dot product with their directional vector and our ds. So then the integral will be, sorry, it is del s f dot dr, where f is the vector field and s is an oriented smooth surface, and n is the unit normal to s, and del s is the positively oriented boundary of s. So now our problem says us to, we are tasked to verify the Stokes theorem for the vector field, which is our yeah, okay. So what our vector field is? Our vector field is x f bar equals to xy I cap plus yz j cap plus zx k cap. Then over the surface S. Okay. So which is the upwardly oriented part of the paraboloid? The given equation of the paraboloid is this. Yeah. Z equals to 1 minus x square. Now for we gonna have this boundary. Yeah. So our boundary curve del S. So the curve where Z equals to 1 minus x square intersects the plane x equal to 1. It intersects with x equal to 1, then forms the vertical line segment for y equals to 2 minus 2 comma 2. Okay, now the orientation. So the surface S is upwardly oriented, meaning the normal vector points away from the cylinder. So what is our step 1 for the computation of this thing? We will now take this. That will be so small. Okay. So the curl of F will be this, which is equals to I cap j cap We all know how to do the cross product, no? This is a determinant. So now, I have to expand the determinant. Then we will get ours equals to I cap of common del of xz by our del y minus del of yz by our del z. So sorry. Then our minus j cap will be common. So we will get our del x of zx and del z of xy. Del so and del x and minus it will be. So lastly we have the common factor k. Then what will be the cofactor of it? It will be del x of zx minus del z of xy. Sorry, I have stated wrong. It will be del x of yz and del y of xy. Okay. Then the answer will be wrong. So it will be. Yeah. Okay. So then what will we get? We will get this will be our 0 and it will be y. As y will be the constant or when y will outside. So it will be our z minus 0 plus k cap will be our 0 minus. Then what is the curl of the function? Finally, we get minus y I cap minus z j cap and also minus x k cap. Now, I did something wrong. Okay. Now the surface integral will be this surface integral of this will be done and the surface is given as z equals to 1 minus x square. Then the parameterization will be our this as our xy will equals to xi cap plus yj cap plus 1 minus x square k cap. And the limits of the x are 0 to 1 and it will be this. So now we have to compute the tangent vectors. They are our del r del x which is I minus 2xk and our del r del y will be our only j because this is y. Okay. So now we have to find the normal vector. N is given by the cross product of both of them. So we will get our n cap is equals to del r del x cross del r del y. Then again we have the cross product thing. Yeah, insert this. Sorry, I wanna insert line. Okay. Yes. And it will be, and another, okay, that can be done after that. So the cross product, we all know that, no, how to do it. So it is 1 0 and minus 2x, and it is 0 1 0. Then we have to draw another line to complete the shape of the determinant. Okay. Yeah. Then it is equals to what? I cap will be 0 minus 0, and the coefficient of j cap will be 0 minus 0, and also no, there will be 1 minus 0. So our normal vector is only k cap. Thus the surface element is, that means our ds is now nda, which is our k dx dy. So now we have to compute the surface integral. How can we do that? The surface integral is s nds, which is our equals to s cap minus zj cap minus xk cap, and it's our k dx dy. Then, as we know that I cap dot k cap and j cap dot k cap are 0, so the integrand becomes only minus x here. So now we have to substitute our value, which is this. Z is equals to 1 minus x square, which is the given thing. Okay, so what can we do? We will substitute it as okay, so it will be our integral minus 2 to 2, and it is x square by 2, minus will become outside, and it is 0 to 1, so our minus 2 to 2, it will is half d, sorry, it will be our dy, no, it will be our dy. And then what will be done? Then it will be minus half, and it's y minus 2 to 2. So the after completing the outer integral, we get this is minus half of 4 and it's minus 2. So the surface integral is now minus 2. So so we have to compute the line integral over ds, and then we have to match the things. So let me change my color first. Yeah. Okay. So the boundary curve del S lies at z equals to 1 minus x square and x equal to 1 is a vertical line. So parameterization of the curve I have done before. So now by putting this x equal to 1 in our parameterized curve, so we will get I and yj cap, and it's 1 minus 1 square. So the k cap, so the coefficient of k cap vanishes now. So it's I cap and yj cap. After this, the vector field along del S is the given firstly, which is our f xy cap, which is this. So we have to compute the line integral at x equal to 1 and and z equals to 0. Now the f becomes y I cap plus 0 j cap plus 0 k cap. That means it's only y I cap. So now we have to compute the line integral. Then how can we do that? So the line integral is our integral of closed integral of del S, and it's f dot dr equals to our minus 2 to 2 y dx only. Okay. So along the boundary curve del S, the position vector will be ry equals to I plus yj, and that will be yeah, r of y will be equals to I plus yj cap. Okay. Then the differential our dr will be what? It will be our dr dy into dy. That will be our j cap dy. So the vector field along the del S is f equals to yj cap. So the line integral becomes f dot j, that is ds f dot dr is equals to our minus 2 to 2 f dot j dy, and it will be our this. Now verifying the Stokes theorem, the surface integral of curl f dot n ds is now found to be minus 2, which is we have this, and the line integral is found to be 0. So conclusion, the surface integral and the line integral do not match, so Stokes theorem is not applicable here. This inconsistency arises because the boundary curve del S was incorrectly described as a vertical segment, when in fact it must be a closed loop around the cylinder's top boundary. Yeah, and it must be a closed loop around the cylinder's top boundary. For the full loop, re-evaluation is necessary. Okay. Thank you guys. Hope you understood.